Hey guys, welcome to another video. So today we're going to do another video on the nice question series. Today's question comes from the Extension 2 syllabus in the topic of vectors. Specifically under vectors, we're going to do a question relating that has spheres involved, right? Equations of spheres, so a little bit different, but yeah, it's a good question. It's the last question in the Caringbah 2023 trial paper. So before I begin, as always, like the video, subscribe to the channel, and tell your friends. Guys, let's dive right in. So Caringbah 2023. Last question of the test. It's 2 parts, 4 marks, and then 1. So let's have a read. 2 spheres, S1, S2, intersect the circle C. So, okay, so you got 2 spheres. When they intersect, it's going to be a circle of intersection and not a point of intersection, right? Unless, of course, if 2 spheres just touch, then it's a point. But generally speaking, if it's overlapping, it creates a circle. Sphere 1 is centered at A. So the center there is ABC, this guy here. It's ABC, coordinate, and center and radius of R. Sphere 2, right? So maybe I'll do this. And then sphere 2 centered at B. Now, B, let's see. A plus M, B. Okay, it looks like it's the center A, but plus M plus N plus P. Okay, that's over here with a radius of capital R. Okay, cool. Everything's real. Okay, good. R is greater than 0. This distance, okay. Distance between the 2 spheres is D, right? That's important. Okay, so it feels like distance between the 2 spheres is D. So this distance, okay, cool. Right, so I've got a radius. Okay, cool. Prove that the circle C lies on the sphere S3. So there's a new sphere which has a diameter. So diameter, so it looks like there's a 3rd sphere here. Diameter of AB. So AB is a diameter there. Only if this guy is true. Okay, cool. Yeah, okay, cool. So, and then part 2, I presume we're just gonna, okay, just got numbers. All right. So the best way for us to visualize what part 1's about, right, is that I've got a sphere with a radius, diameter of AB. So what I'm going to do, I'm going to draw the line AB like this. All right. And I'm going to draw a sphere that has this. Okay. Just try to draw this properly. That's probably as good as it's going to get. Well, so let me just erase that bit and that bit so I can write AB better. So I've got AB. Right, this is A, this is B. Yep. And there's a circle, right? There's a circle sort of looking like, now, a sort of circle looking like this guy here, right? Yeah. So I'll just draw a circle that looks where it just touches it, right? I think. We can assume that it just touches for now. Yeah, where this circle is circle C, right? Now, prove that the circle C lies on this sphere, right? Lies on this sphere, which has diameter of AB, right? So now, what's the diameter? So firstly, I'm going to figure out, so diameter, right, D, right? Is that D? Yep, D is equal to the magnitude of AB as a vector, right? Yeah, between AB. Now, if I find the magnitude, let's just find that first, right? AB, now I know the coordinates of A, and I know the coordinates of B, so it's like square root of, if I was to do the algebra, I think B is what, A plus M? Yep, A plus N, yep. So it'd be like A plus N minus A plus B plus N minus B plus, let's see, CP. Sorry, C plus N. Sorry, C plus B. C plus P minus C squared, right? The A's, B's, C's cancel out, so therefore D, maybe I'll go D squared, right? Equals to M squared plus N squared plus P squared. Cool. Now, why do I know that that looks like it's on the right track? Because that is the same as this, right? Yeah, that's cool. Now, in this question, it says, prove that this is a circle given if and only if this guy, right? So, if M squared plus N squared plus P squared equals to little r squared plus capital R squared, that's the sum of the 2 radii, right? Therefore, right? The diameter squared, d squared, equals to r squared plus r squared, right? That's important, right? So this is telling me that in this question, the diameter squared equals to little r squared plus big R squared, right? Now, what is the little r squared and big R squared? They're the radii, right? Now, if you picture a point, let's say I picture this point here, right? Let's call this point, I don't know, call it P, right? In this diagram, where is the little radius squared? It's this side, this to like, if you can picture, if this guy is lying on the seat, it basically it's this guy to the top, right? It's from here to the top, right? This guy is little r, right? Where's capital R? Capital R is the radius of the big one. It goes from the center all the way to the circumference, right? So from here to here, right? That's capital R, right? And right now, I've been given that d squared, which is this side here, this is d, right? AB here is d. And I've just proven that d squared equals to r squared plus r squared, right? Yeah. So therefore, what that implies is that it implies that it's a right angle over here, right? Why is that super important? If that's a right angle, then I can demonstrate that this sphere, so that this is a sphere, right? Because there's a right angle subtended on the circumference, right? So what that means is, guys, if I say, as part of my workout, let P lie on C, let's see, let P be a point on C, right? On the green circle, right? Yeah, where d squared AB, right, equals to, now I know that r squared, right, is equal to AP, right, equals to AP squared plus, and I know that capital R squared would be PB, right, as a vector, PB. Yeah, because I've proven this, right, therefore I can conclude using Pythagoras' theorem. Now, you can use dot products as well, right? You can demonstrate that the dot product is 0, but let's use Pythagoras, right? Therefore, angle APB equals to 90 degrees, right? And the moment you prove that it's 90 degrees, right, we can demonstrate that it's a sphere. So therefore, I've got nibble space. Can I just quickly move this up here? So therefore, yeah, once I've proven that, then P lies on the sphere S3, which has diameter AB or D. Does that make sense? Because it's you can put in brackets angle at circumference equals to 90 degrees. Yeah, that's a bit of circle geometry there for you, which is technically out of the syllabus, but there it is. So let me say this again. The way we've proven that is basically we let AB be the diameter, right? We used just the magnitude formula between 2 points, right, to demonstrate that d squared equals to m squared plus n squared plus p squared, right? In the question, it says if m squared plus n squared plus p squared is equal to d squared, right? So if m squared plus, if this is true, right? If m squared plus n squared plus p squared equals r squared plus r squared, right? That's basically telling us that the diameter squared equals to the two radiuses squared added together, right? The sum of them. We know then, if that's true, diagrammatically, right, these two sides equal to this guy. That's Pythagoras, right? If it's Pythagoras, it'll subtend the right angle on the circumference. If it's a right angle on the circumference, it's a sphere, right, where the point is, right, where P is. And since P lies on C, P also lies on the circumference of the sphere. That's exactly what I want to prove, that the circle C lies on that. Every point on circle C lies on the sphere. I've done it, right? So therefore, yeah, therefore, C lies on S3. Yeah. That's really the thrust of the argument here. And then that's part one. For part two, it's just a numerical application of this, right? So basically all it's trying to say is it basically presents you with two spheres, right? Just like above, where sphere number one, sphere number two. Now with sphere number one, the center is 0, 0, 0, and the radius is 5. Now using the same notation, right? So actually, you know what? I'll call this guy, just like I did up above, this is coordinate A. And then for the green, it presents itself as coordinate B as center 3, 4, 12. And the capital R is radius of 12. Now, why am I using these letters? Because you can map them, because in the guy above, this is like A, this is B, this is C. Now, this is A plus M, so M must be 3, N is 4, and P is 12. Got little r, got capital R, right? So show that the interval joining the centers of the first two spheres. All right, so let's hence show that the intersection of the spheres is a circle lying on the third sphere. Okay, cool. So once you've done that, right, we can go using the part. I'll do it over here. For part two, yeah, I could go m squared. So yeah, because from part one, I got this guy, right? Plus mp squared equals to r squared plus r squared, right? Yeah, I need to prove that if that's true, right? So if I can demonstrate that, then I can use part one. Does that make sense? So show this, right? Because if I can show that, then use part one, and then part one says that this is the intersection circle lies on the sphere, right? That's exactly what they want. So I go left-hand side equals m squared plus n squared plus p squared, and I know from this one, was it 3 squared, 4 squared? 3 squared, 4 squared, 12 squared. So 3 squared plus 4 squared plus 12 squared. What's that? 169. 144, yeah, okay. Right hand side, little r squared plus r squared. And what's that? 5 squared, I think, plus 12 squared, which is 169. Therefore, m squared plus n squared plus p squared equals to little r squared plus r squared. And then all you got to say is using part one, right? There is, so the, now let me see what the question is saying. The intersection, the circle, you can say the circle of intersection lies on a third sphere. So guys, I like this question because when it comes to spheres, a lot of the times it's a bit confusing, but the key point here is that when you have an intersection of two spheres, right, if I can demonstrate, right, that the circle of intersection lies on a circumference of another sphere. So if I can, to prove that it lies on the circumference of another sphere, I prove that the angle subtended on the circumference is a right angle, has to be a sphere, right? Once you've done that, part two, it's just a matter of finding the parameters MNP, RR, right? R capital R. Once you do that, prove that it is equal to, therefore you're able to use part one and conclude that the circle of intersection lies on the third sphere. Hopefully that was good. Nice little question, guys. If you like that, like the video, subscribe to the channel, and tell your friends. I'll see you guys at the next one.